Hi guys, in this tutorial I'm going to solve question number 6, paper 42, June 21. Particle A is projected vertically up from the level ground with initial speed 30. A particle A with initial velocity 30. At the same instant, particle B is released from rest, 15 meter vertically up, 15 meter. This is particle B. Released means B is equal, U is equal to 0. At the same instant, particle B is released from rest, 15 meter vertically above A. The mass of one of the particles is twice the mass of the other. So we have now two cases. If mass of A is m, so mass of B will be 2m. Or if mass of A is 2m, so the mass of A of B will be m, but the same information. During the subsequent motion, A and B collide and collides to form particles. It means form only one particles combined together. Find the difference between the two possible times at which C hits the ground. First, when the particle A move up and particle B move down, they hit, say, at a point in between. Let's say this point. In this case, the displacement covered by particle B and the displacement covered by particle A, their sum is equal to 15. You can find the time and you can find the displacement and you can find the velocities of each. This is the first step. So they meet at this point, try to find the time. The displacement covered by particle A and displacement covered by particle B is equal to the distance in between, which is 15. UT plus half of AT squared, this is for particle A, plus UT plus half of AT squared, this is for particle B, is equal to the distance, which is 15. The positive direction is up. Initial velocity for particle, if we have A, is equal to 30 times T, 30 times T plus half negative 10 times T squared. We use it as a distance. Initial velocity for particle B is 0 plus half. Acceleration is positive 10. T squared is equal 15. Solve the equation. 30T is equal 15, so T is equal to 0.5. Also, you can find velocities of each and you can find the displacement. For displacement, if say displacement of A, which is UT plus half of AT squared. So the initial velocity is 30, the time 0.5 plus half times negative 10 times T squared, which is 0.5 squared. Find this displacement by calculation to get S of A. Or you can find displacement of B. So they meet at a height by calculate the value of S. Zero times 0.5 plus 0.5 times negative 10 times 0.5 squared. So the answer will be 13.75. 13.75. And also you can find velocity of A and find velocity of B. V equals U plus AT. So velocity of A is 30, negative 10 times 0.5. So V of A is equal to 30 minus will be 25. And velocity of B, 0 plus 80, 10 times 0.5. So velocity of B is equal to 5, but in opposite direction. So we can write it -5. Negative refers to the direction of the velocity of B. Now, after finding the displacement velocities of each, now we'll use the momentum law. In general, you have to know direction before start. Now, before the collision, this is particle B and this is particle A. If we use positive direction up, so M A U A plus M B U B equals M A V plus M B V, because now it's one particle, so we can combine and write like this: mass of A plus mass of B, all multiplied by V. But we have two cases. The first case, when we use mass of A is M, mass of A is M, and this is 2M, then we'll repeat it again when mass of B is M and the mass of A is 2M. Mass of A is M, U of A before the collision, which is 25. Mass of B, which is 2M, velocity of B is -5 because its direction is down, is equal to summation will be 3M, M and 2M times V. Simplify, 25M minus 10M is equal to 3MV. We can simplify more, 25 minus 10, which is 15M, is equal 3MV. Cancel, we can divide it by 3M, so V is equal to 5. And now it's clear its direction is up. By the same way, in the second case, repeat it again, but mass of A now is 2M, velocity is 25, plus mass of B is M, velocity is -5, is equal 3M times V. 50, 2 times 25 is 50M, minus 5M is equal to 3MV. 50 minus 5 is 45M, is equal to 3MV. So divided by 3, so the answer will be 50. And also now it's clear its direction up. Now for particle C together, now it's clear its velocity is 5, but its direction is up. And there is a displacement between the particle C and the ground. If we use displacement to write it -13.75 as displacement. And the second case, particle C still move up with velocity is 15, and here is velocity, which is 5. And also the displacement between the particle and the ground is -13.75. So we'll calculate the time taken from the particle C to back to the ground again. We can use S equals UT plus half of AT squared. The displacement is -13.75 is equal, initial velocity is 5 times T plus half of the particle move up, so acceleration is -10 T squared. By the same way, -13.75 is equal to UT is 15T plus half of -10 times T squared. Calculate the time taken from each to back to the ground. The first one, by solving a quadratic equation, write it simplified in a standard form, will be 5T squared minus 5T minus 13.75 is equal to 0. By solving this equation, you will get two values for time, one positive and one negative. we'll use the positive sign, so the time will be 2.23. And also this equation is 5t squared minus 15t minus 13.75 is equal to 0. By solving this equation, you will get 3.736. Now, this is the time 1 and this is the time 2, and he asked to get the difference in time. So 3.736 minus 2.23, and you can write your answer correct to 3 significant figure will be 1.506. So the final answer will be 1.5. That's it. Thank you.